In this video, I would like to show you how we can place and configure cameras so that you can always jump back to predefined viewpoints, because you don't want to do screenshots of your three-dimensional space, because if you have to redo a rendering, you want to be able to jump back to exactly that view, which is why we're going to place different cameras. And then I will show you how we set up the information for the render engine. So instead of getting grainy preview renderings like here, we are ending up with smoothly rendered and more or less grain-free final images for presentation purpose. And I'm going to use one of my current projects, which is a hospital environment, just as the example. So let's go back to the 3D view, and you see every time when you, for example, zoom your camera, see I'm in camera mode, the engine re-renders that image and updates it, and it starts very grainy and then gets cleaner and cleaner and cleaner. And the way how Blender actually works is simply that it is using kind of like a process that it samples certain points and then continues and continues and continues until, for example, the image gets really clean, and then you can basically stop it. And each pass of kind of like a cleanup process, if you want to call it that way, we simply call a sample. So you see actually up here when you render, it says path tracing sample 2020. So if I zoom and you see this number actually resets to 0 and then goes up, and you see when I reach 20 samples, this preview basically stops. So when I go to the camera and I go to sampling, you see here preview 20 and render 500. So if I type in 25, you see actually it added 5 more steps. It doesn't really do much. So maybe 100. Now, because this is actually an interior space, so light is being blocked by, for example, the ceiling, etc., I need a lot of samples to clean up this grain. So, for example, I figured out something with 500 or 1000 actually will be pretty sufficient to clean it up to a certain degree. So this is actually step number 1 when you do, or before you do your actual rendering. Do one test rendering with a really high number and pay attention to the grain. And the moment you kind of like start not seeing that grain anymore as noticeable, memorize the sample number, because then you kind of like found the amount of samples you only need for rendering. Now keep in mind, if you want to print an image, the printer, the laser or the inkjet most times have a certain grain because of their printing process. So this rendering doesn't have to look perfectly smooth. If you have a little bit of grain, you can keep it because the printing grain will mask or hide it. At the same time, actually, I prefer to remain a little bit of grain inside the image because it simulates the grain of a film. Digital rendering sometimes can look too perfect, and it's kind of like not really natural, a little bit too artificial. Obviously, too much grain you don't really want, so kind of like it's an aesthetical balance you have to find. Okay, so let's actually go ahead and first maybe position our cameras. So let's go to this level, because here I have actually my camera, and just for the sake I moved this camera to this layer because I have some other stuff there. So for example, here I have one camera, and it is looking into that space from there. So let's say you would like to have maybe a view into your space, maybe from here. So I would have to create a new camera and then actually move it to there. So for example, what I can do is simply I slice my viewport open, and then here I go to an orthographic view, press 3, Shift A, open a camera, add a camera, not open it, and then move my mouse to here and press Control 0. So now you see actually the space through this camera. And I like working this way because in the top view I only can move this camera left and right, up and down. I can't really rotate it. If I go to a side view, then for example I can rotate it up. So I feel like it's very often very manageable when you try to do those types of transformations only in an orthographic view. Okay, let's add another camera here. Let's rotate it to there. Control 0 with my mouse there, and I see that there. So you see, this way you can easily create different cameras. Let's maybe say I would like to have one camera also for the outside. Now you're working on an exhibit design, so obviously you want to show most of the stuff from the outside. So here, for example, I have my camera kind of like shown there. I can move it, for example, up. And then, for example, well, we have to rotate this camera. So I switch to local, and then I can go to rotate. And you see then actually those X, Y, and Z axis rotations are aligned up with the way how the camera looks. So now if I click the red ring, you see I can actually rotate this camera down along its own x-axis. See, when I click on move, you see this is the x-axis, Z and Y. Let's say I also would like to have a camera straight from the top. So maybe Shift A camera, move this camera up, go to a side view, rotate this one down. So I see up here positive 90. Hold on. There, 90. So I can type in 90. Also, as a refresh, if I press N and I go to the rotation, there you see also all the rotation values. So everything set to 0 makes the camera look straight down. Let's press Control 0, and then here I can press G, maybe move this around a little bit, G and then Z and Z, move it, for example, away from the scene. So I can see, for example, my object straight from the top down. Okay, so that's pretty much how we can actually configure and set up the cameras quite easily. Now the next step we have to do is specify the dimension for our pixels. So how big that image should be. So for example, X and Y, those are the amount of pixels you have for the left and the right side. And you see this 1500 by 1122. This is kind of like representing the width and the height of an image. Now let's go actually to Photoshop for the moment. So let's say we make a new document, and this document should be 11 by 8.5, 150 dpi for printing purpose. Okay, so the reason why I did this is simply I would like to know how many pixels do I have. So 1650 by 1275 is kind of like the amount of pixels you need if you want to make an image that can be printed on the size of an 8.5 by 11 sheet of paper in good sharpness, hence the 150 dpi. So if we, for example, cut this by half, then actually we get the quarter size of a page. So this way, basically, if you know roughly how big your image should be on your presentation board, there's no reason by rendering, for example, an image out, let's say tabloid, if at the end it's going to be the size only of letter. So let's go back to Blender. So for example, here you see 1650, 1120. So this is kind of like close actually to the 8.5 by 11 page. Down here you have a 100% slider. Now what this actually means, if we do a rendering now, it uses this amount of pixels. If we type in 50, then actually it renders half of this, which actually will result into kind of like an image that is half of the size. So basically it fills a quarter of a page. So instead of always changing the numbers, you can just once put in the numbers for a page. So again, let's go back to Photoshop here, 1650 by 1275. And then if you only need half of a page or even less, you can simply work with the percentage slider and then just forget about always recalculating the correct amount of pixels. Okay, so that was for dimension. By the way, I forgot to say that. It's also important that you keep in mind that you only can specify this number once, and this actually applies for all cameras. So you cannot, for each camera, have a different resolution. But for example, here, let's say we want to see everything and render it. That's fine. So let's say I go to this camera. But maybe here all I want from this rendering is actually maybe this part. So you see inside the camera, when you press Shift B, you can draw a selection, kind of like a border rendering. And then inside dimension, you have something called border and crop. So what this actually means, border allows you to create a final rendering based on the red rectangle, the selection you created. And then with crop, you tell the software once you're done with rendering, it saves the image only to the format of what you have included inside the rectangle. So everything to the left and the right will be cropped away. So your image will only be this big. Otherwise, you would get an image that is as big as a letter with transparent left and right sides. That's not really what you want. If, however, you do not want to do the border rendering, you can either turn this one off, or here press Shift B and drag all over the screen, and you see then it renders everything. Okay, so that for dimension. So the next few things you want to turn on is go to Film and click Transparent. So when I click Transparent and I do a rendering, you see actually that everything outside my environment, where I have no geometry, is going to be transparent. Currently I show my background image here. Let me turn this one off. And for example, this really is very noticeable when we go to an outside view. There we see now actually it just renders your object, but the white environment we have set up is going to be removed and replaced with transparent pixel information. So you can, once you're done with the rendering, you can easily take this and then paste it into any presentation, and you will not have a background you need to remove. So for example, if I turn this one back on, you see now the background is filled actually with this white world color. And you see here that's the color from our world. In my case, I'm going to keep actually the white material turned on, so I do not want to have the transparency gone, because I also like actually how this actually is being filled from an interior view. From an exterior view, maybe you want that to be different. So let's go back to the rendering. You go ahead and go to Output. And you want to keep this one on RGBA and PNG, so this is good. And then the last thing that's important for you to set up is performance. Now you see here this auto tile. I have something else installed, so that's the reason why you don't see it. What's important for you to know is actually this tiling, 64 and 64. So what this basically means, it renders small tiles with 64 pixels by 64 pixels. And I have to switch this one actually to CPU. I have a different render hardware, which you don't, so you won't really see this option. So CPU is just what you can only use. So we have set up our cameras, we have set up our dimensions, we have set up actually our sampling for the final rendering. So we're actually good to go to do an actual rendering. So you can pick then actually like your preferred camera. So you see you can click a camera and then control 0 inside this camera view. Then you switch to it. So every time when you go to a specific view, then you're ready to render that into an image. So to do that, actually, you can go to render and render. And now you see here those small buckets, 64 by 64 pixels, and they continue working and working and working. And once, for example, one bucket reached the 500 samples, then actually it goes to the next tile. There you see it actually, how it actually jumps. So you just wait till this whole area is filled, and then your image is ready. I'm going to press escape, and then I'm going to go to slot 1, because there I have my pre-rendered full view. So this is, for example, now if an image that is finished rendering, and I would like to save this one. Now to save the image, you can go to Image, Save as Image, and go to your desktop or wherever you would like to save it, type in the name, click Save, and that's it. Then you finished your first rendering and saved it as a file. Then you can go to the next camera, for example, go to a different slot if you don't want to overwrite your previous slot, and click render, and then it creates the next image. Now you might ask yourself, well, what are these slots actually for? Well, they're very useful, for example, when you want to have different renderings inside Blender. So let's say you change a material and you want to be able to flip forward and backwards between these two images. So instead of doing the two renderings, quitting Blender, going to the desktop, opening the two images, and then comparing, we can, for example, simply do this in Blender by simply rendering into different slots. And then with J, you see an Alt J, I can switch forward and backwards between the different slots or images. And each of these images you can save into a separate new image onto your hard disk. Okay, so I think this actually covers everything in terms of how to do the renderings. I would like to do one last demo simply to show you how the crop function works. So for example, here I would like to only have this area specified. By the way, you see how this view actually updates because I have this crop turned on. So, and then if I click render, you see this whole thing is only as big as the selection. I just let it render for a second, and I'm going to press escape. Okay, let's press escape. Let's turn this one off. Okay, it doesn't do anything anymore, but if I would save this image now, so let's say save image. Let's call this one test. Okay. There's, for example, some of my tests I did actually. I was working on the kind of like the structure here. So there I did this border rendering, including this crop. Let's see, where's my test now? There's my test image. So there you see actually the image is really cropped to what you have specified as being the border rendering inside your camera. Okay, I think that actually really is everything.